do the whole prep assignment?
I did. So
Okay.
I was doing it trying to stay awake while I was listening to him talk.
Yeah.
So, and realized that I wrote some things wrong on my original notes.
Ah, well, like my issue is that he teaches us things that's different than what's in the book, and so it's hard to keep it straight. Like I asked him a question last night about the, I think it wasn't the margin of error. It was
the confidence level, because I remember, because he was questioning whether he was teaching it right or not. Because he's like, am I teaching it the same way that the book is saying, or am I teaching something totally offhand?
No, actually, you know what, well, that too, but there was something later. I asked him about the margin of error. So they say he says to do n equals 0.25 and then parentheses 2xm squared. But the book is different. I don't know. It says something is different. I wrote it down somewhere.
Yeah, because the margin of error is the n equals z score divided by 2m.
Right.
No, that's the sample size. No, that's the sample size. Sorry.
No, and that's the one. That's what it is. It's the sample size.
Okay.
The book says to do it different. He says to do it times 0.25. Because in his head, when you go through, it's like having a 1 over the z and 1 over, or a 2 with the n, because it's a division problem. So it's like your numerator and your denominator. It's really like 1/2. He says when you square that 1/2, it's really a quarter. So just cut that out and multiply it times 0.25. He explains it, and I asked him why, and he literally went on for like 15 minutes explaining.
He pulled up the Excel thing and did all of that.
Right, which was a little bit confusing.
A little.
Yeah, but yeah, what he said to do was different than what. Yeah, it was for the numbers. So when you're looking for the numbers, you've got z over 2m squared. And he just says go 0.25 over z over m. Right. So he does it a little bit different, but he said you get the exact same answer.
Yeah, if anything, since lesson 16 is I am taking all my calculations like 5 or 6 numbers out.
I was going 8, literally 8.
Or if it was like, yeah.
Yeah. Okay. You ready to take this test then?
Yeah, I think so. I'm not pulling up SPSS. So
let me look and see if we need anything on that.
It's the confidence level thingy. That's the only thing that I noticed that we would need, but you can calculate it by hand.
Yeah.
Even though it's a pain in the butt.
No, that's fine. I typically do that anyway. I mean, that's the way we originally learned.
Well, the one thing that I noticed when I was doing it the one time is that when I went in to put in something, it rounds up the
calculator does.
Yeah, it rounded up something, and I was just like, okay, well, that's not what they're asking for. They're not asking for 50%. They're asking for 47.
Yeah. Okay, so are you on the quiz? Are you ready?
I'm getting there.
Okay. Let's see if I can find here.
I have it open. I really do. The good news is I don't have to raise a virtual child anymore. Today is the last day of that.
Oh, that's good.
Yes. One less thing for wonderful psychology.
What requires that?
Okay. All right, group meeting. Yes, I did that. Yes, I did that. All right, so P is the true population proportion. Yeah, because P hat's the sample.
Okay. So I calculated out 4, and yes, because you end up with 25 being greater than 10, and then 90 being greater than 10.
Okay, is it 25 or is it 10? Because
No. He worked through this last night and showed us really the simplest way to do it. He you take, uh-oh, now that I'm doing it, now I'm confused.
Because I started working on the homework
Uh-huh.
and I did the 20%, which is the population, but that's not what they did for the answer key. They did the p-hat.
Okay, so okay, for this one's easy because they're asking, okay, so you know what n is, you know what p is, and you know what the p hat is. Doesn't really matter about the, oh yeah, you do know p hat. So all you have to do is go 100 times 0.25 because it's n plus p has to be greater than, or n times p has to be greater than or less, or greater than or equal to 10.
Mm-hmm.
So that gives you 25.
Right.
And then for the other one, it's n times 1 minus p. So you go 100, or 100 times 1 minus 0.10, so it's 0.9. So 100 times 0.9 is 90, and that's greater than 10.
Okay, hold on just a second. Girls, are you ready to go to school? Okay. Do you have your stuff for the readathon today? Do you have your book for readathon? Okay. Okay, yeah, so I'm just confused because the
I think you're,
P or is it p hat?
it is,
When you're trying to do that.
oh, it's p. Yeah. I used p hat. They confused me with p hat. Okay, so let me calculate it out for that. N minus 1 minus 0.25. It's still, you end up 1 minus 0.25 is 0.75. So you still end up with 75 versus 90.
Okay. So it's still true.
Right. Okay. Number 5 though, I'm not sure. It says the requirements for conducting a hypothesis test are satisfied. What are the requirements?
It's the same thing.
It's the same thing. Yeah. Confidence. Okay. So what are the requirements for conducting a confidence interval different than required? Check the cards. Same thing. Is that weird that that's the same thing?
See, that's where I think okay, thanks. Okay, so confidence level. Hold on. Dadgummit.
Okay, because, okay, if you look at the,
Okay, so confidence level, I have a note, is p hat. Whereas hypothesis
it
should
is,
be
you're right.
p.
Yeah, because if you look at the homework 17 answer key, it is p hat. Okay, so 5 for sure is true because that's the one we just worked out. And then let's do this for p hat. So it's 100.
I don't think the first one is because it's 10.
Well, then it would be, then the answer would be 10.
Right, but I don't think it's satisfied on the second one.
Okay, so
Damn it. She has my phone, which has my calculator.
No, you're good.
Okay.
0.9. So no, that's the one still equals, and it still ends up with 90.
Okay.
So if you've got 1 minus 0.1, right? That's 0.9 times 100 is 90.
Yes.
1.
Okay.
Yeah.
So they're both true.
They should both be true.
Okay.
Okay. A study of first-degree murder trials was conducted in another state. A random sample of 60 people, n equals 60, on trial for first-degree murder was taken. Of these, 45 were found guilty. 45, so 45. Okay, find the p-hat, the point estimate of the proportions returned found guilty in the state. So that would just be the 45 divided by 60,
Yep.
0.75.
Yeah. So what did you get?
0.75.
Okay. 0.75. Okay, that sounds right.
Okay, so p-hat equals 0.75. Okay, so the 95% confidence interval. Okay, so it is, I need to just find the formula.
So 95% is
Yeah,
that, and this is
1.96.
where this is where you could just plug it into that thing.
See, and he found that thing so quickly last night that I wasn't like 100% sure. Okay, so there's the applet. So if I go back out of the applet.
Yeah. It's like an applet, but it's run through SPSS.
Okay.
Does that make sense?
SPS tools. But what's it called? SPSS tools?
No, I just copied the link. Is what I did. So it's
categorical data analysis.
Yeah, that thing.
Oh, but you know what? That just is pulling me up like a. No, that's pulling me up like an Excel. Well, is it in Excel? Is that?
Yeah, it's through Excel.
Okay, so our X is 60.
X is 45. Your N is 60.
Oh, 6. Oh yeah, I got them. I stacked them wrong. Okay.
Yeah, 45 over 60.
Stop. Stop it! It's telling me I can't. Okay, hold on a second here. Enable editing. Okay, it wasn't letting me do anything to it.
Okay, so you just need to do reading, and we'll go over spelling.
No, that's what I was doing.
Oh.
Okay.
Have a good day at school. You might want to take a jacket. You won't need it this afternoon, but you'll need it this morning.
45, 60, right?
Yeah, 45, 60.
If he has 0.75, confidence level, they've got 0.0559.
Okay, none of those are our options.
Yeah, oh no, there we go. Sorry. They've got confidence interval written in a couple of places. Okay, it's 45 and 15.
Nope, that's not right.
Okay, here we go. We got more here. We got 0.640.
Okay.
It's the one proportion Z test, right? 0.640 and 0.860.
Okay, so so it's B. Yes.
Test. There's my.
Okay.
Oh gosh, where's my test? P. Okay. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval?
If you increase, it goes, doesn't it decrease?
I think just so, like, because it makes it,
like the other one?
Well, if we went from 60 to 80, so 80.
Doesn't it become narrow?
It makes it 0.454 to 0.671.
So it goes
a little bit wider. Because if I go 0.860 minus 0.640, I get 0.22. 0.671 minus 0.454. I get, oh, it's a tiny, tiny bit narrower.
So the option is stay the same, decrease, or increase.
Well, it goes from 0.22 to 0.217.
What does?
The difference between the two. Like if you take and you calculate. Okay, so if you
So did
subtract,
it go down or did it go up?
well, it went down from 0.22 to 0.217.
Okay, so then we'd say it decreases.
But
Because
it
we
is
don't have, yeah, because we don't have a choice of narrow or wide. We have a decrease, increase, or stay the same.
But would that round up to 0.22, which is what it was, the difference between the two? Or is it based off of the z-score? Well, the z-score?
It's not, it's based off of the sample size. When you
No, I'm
increase
wondering
the sample size.
if we look at the z-score, if that would change anything. No. Oh, because that doesn't have anything to do with that. Okay.
The pillow's not going to fit in there. It's not a small pillow. You have a smaller pillow.
This is a small one.
You need to put the blankets in and then carry the pillow. Sorry.
No, you're good. So what do you think? I can never remember. I feel like I've written this down so many times that I can't.
Yeah, I know. I've got to go back to that lesson and figure out, and I'm pretty sure I'm going back over my notes.
Let's see.
Okay, increasing the confidence level will increase the z-score and margin of error, wider confidence interval. So that was with confidence level with sigma known. Increase the sample size, decreases the margin of error, becomes
So
narrow.
it does
So it's
go down
decreased.
just a tiny bit. So that does work. Okay. So decrease. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest n that can be both requirements still be? What? What is the smallest n? Someone
This
needs
is
to.
where we do the algebraic thing
Right.
that
But
I
the
did.
way they word that's retarded. What is the smallest n can be and both requirements? Like, who wrote that? It wasn't an English major,
No.
you know? I'm like, who did that?
Yeah.
Okay.
All right. So n times 1/2 has to be greater than or equal to 10. So that will be 20. That n's going to be 20.
What is the smallest n?
Minus 1/2. So that's 1/2. So, okay, so that will be 50 or point, sorry, 0.5 times 10. Isn't that 50? Or 5?
Hold on though. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P equals 1/2. What is the smallest n? So, or we need to find the smallest n.
Right.
And what is the formula for that one?
Use the NP is greater than 10. And then the N times 1 minus P is greater than 10. You do both.
Okay, give me one quick second.
Yep.
Hey, I'm in my class. Can I call you back? Okay, bye. Sorry.
It's okay.
What is the smallest that n can be?
It's
I think
20.
this is, and it's 20.
Yeah.
So tell me how you did that one.
Okay. So you know what P is, which is 1/2.
So 0.5.
Mm-hmm. So do 0.5. You do 10 divided by 0.5.
Okay. Okay, it was 20. Yeah, 20. Okay. And then what about for the other one?
The other one is 5. So the smallest it can be for it to be true
It's
is
going to
20.
be 20. Okay.
Have a good day. Mm-hmm.
P is 1/10. So
do the same thing again.
So 10.
So the first one will be 100. And then the second will be whatever 1/10 is.
0.1.
Okay, 0.1. So it'll be 10 divided by 0.1, which is 100.
Okay, 10. Okay, hold on. 1 minus 0.1, right?
Oh, wait, that's 90. But
Yeah,
it's still.
yeah. Okay. So the answer's gonna be 90 then?
I think that one's 100.
What is
It
the
could be-
smallest? It has to be the smaller of the two, though.
I know, but last time we did that.
And it was right.
I know. Okay, I'll go with
Oh, no,
90.
no. The smallest of the two. Yeah, it has to be the larger. It has to be the larger. It says smaller, but you choose the larger. You're right.
Yeah.
So it has to be 100.
100. Yep.
Okay.
Sorry.
Okay, for questions for water quality study in the reading, about 60% of the microinvertebrate water quality indicators have historically been associated with good health. Okay. They collect new data, this time 80 and 38. The conditions for conducting a hypothesis test are satisfied. Do we even need any of that other information besides the 80?
Yeah, because you need the 38 over 80 to get the p-hat, so you can verify that the hypothesis test is.
No, I mean that stuff up top, the hypothesis test or the level of significance. We don't even need that.
Well,
right?
you don't need the 60 because that's your hypothesis. It gives you your level of significance, so you will need that.
So according to my little calculator, let me do it on this other one too.
Yeah, I got my calculator or my phone back.
Divided by 80. Yeah, 0.475 is
Okay, so P is 60. So an N is what?
0.475. Well, N is 80.
80 times 0.6. Okay, that's 48. Larger than 10. Great. 1 minus 60 times 80 is 32. Okay, so 11 is true.
Okay. Okay, and so then the p-hats, it's the 0.475,
Is 38 divided by 80.
right?
So yeah, 0.475.
Okay. Okay, and the test statistic, let's find.
Oh, that thing.
I know, I have to make up a thing. Wait a minute.
All right, so p-hat minus p. So 0.75 minus 0.6 divided by,
You need your standard deviation to divide it by, right?
yep, the square root of 60 times 1 minus 60 divided by 80? 80.
Oh, good grief.
Yeah, this is what messed me up last night because I wrote that one wrong. I put p-hat in my standard deviation. So I'm like, how about that? Yeah, so that'll throw you off.
Okay, standard deviation. I'm trying to find where I wrote this crap down.
You wrote the formula for number 5 on your prep.
417? Okay. So it's p hat minus p, right?
Yes.
Okay. So our p hat is 0.475 minus 0.6 divided by P 0.6 times 1 minus 0.6 divided by n.
Okay,
that
so
right?
standard deviation, I got 0 or 0.054772 and so on.
Okay, let's see. 0.6 times 1 minus 0.6. Where? Equals divided by 80.
Don't forget to square root.
Equals. You get
Did I get what? Sherry, what was the answer that you got? You cut out.
hello? Can you hear me?
I'm here. Yeah. Okay. So I got 0.05477722. Sherry. Hey. Yeah, we can do that. Okay.